Good evening. Sorry. Good evening, ladies and gentlemen. Thank you to be there tonight. It's my pleasure to introduce you the speaker tonight. Our speaker is Dr. Damian Evans. He's a research fellow at the EFEO, the French School of Asian Studies. He's based actually in Siam in Angkor, Cambodia. Actually, Dr. Damian Evans studied archaeology at the University of Sydney and has been a long-term fellow at the University of Sydney and a very active player in one great project which has been going on during the last 20 years called the Greater Angkor Project. And Damian actually started his research on cartography and mapping in Angkor that was about 15, 16 years ago, and has been very active in the development and use of remote sensing and geospatial techniques applied in the case of Angkor. After his PhD in 2007, he was posted for the University of Sydney in Angkor, in charge of the center there, until 2015, when he joined the EFEO. And since then, he has developed new technologies, new ways of mappings. In particular, he has been the leading researcher of a new project in 2012 for an international consortium applying for the first time in Southeast Asia for archaeology, a new technology called the LiDAR he will talk about. This project has been so successful then Damian proposed a new project last year, which has been highly successful, and I'm sure that he will show us today some of the first results of his very new data and how it's changed our vision of Angkor. So I've been already too long. Please welcome Damian Evans.
Thank you very much, Christoph. Thank you also to the Society for inviting me to speak here this evening. It's an honor to be here, and it's particularly fitting actually to be introduced by Christoph, who was actually responsible for a large part of my education in this kind of things in Angkor over the years. The types of projects that we've been interested in are different from most of the projects that take place at Angkor. So there must be about 10 or 15 different international teams working at the World Heritage Site. Almost all of those teams are focused to a large extent on the restoration of the temples. Our joint projects have been quite different in nature. They've been research-oriented, looking not so much at the temples, but at bigger picture questions, questions about the lives of the people who built the temples, the types of cities that they lived in, and in particular the question of what happened to Angkor, such that a sprawling metropolis that perhaps had 500,000 or 750,000 people at its height declined to the point where it consisted of just a few villages with a few thousand people in the 19th century. And so these are the kinds of questions that we've been looking into, addressing largely with remote sensing. In the beginning, using aerial photographs, and in the early 2000s, increasingly satellite imagery. And then, as Christoph mentioned, in the last 5 years, in particular harnessing the power of this technology of airborne laser scanning, or LiDAR, and its unique ability to basically see through the vegetation that obscures the traces of the cities that once surrounded these well-known monuments at Angkor. And so I'll deal with this a little bit later in the presentation, but basically the traditional view of temples like Angkor Wat, surrounded by the forest and surrounded by the moat, is now completely transformed by this technology, which essentially allows us to lift the lid and strip away that vegetation and reveal the complex and highly structured landscape that lies beneath the vegetation and was previously obscured from our view. So, as I said, this is quite different from the traditional approaches to Angkor, which have largely been focused around restoration of the monuments. As I mentioned, most teams today are focused on that particular issue, and this has always been the case, really, for the last 100 years of work on Angkor. And it's the reasons for that are obvious. The temples were mostly in a very, very bad state of repair, and it's quite urgent to consolidate and to prevent further decay. So we know a great deal about the temples. The other traditional sources of evidence, of course, have been the Corpus of Epigraphy. I think there are now about 1,300 documented inscriptions from this particular period, which are highly informative in some respects, but frustratingly silent on other issues. They're also quite often not particularly reliable and very often fragmentary, as you can see here. And so they're very problematic as the main source of historical evidence for what happened at Angkor, particularly for archaeologists. Because the inscriptions don't really tell us the kinds of things that archaeologists are interested in, about things, how things worked, how things were going wrong, and this kind of thing. And so the focus has always been on the monuments, on the inscriptions, on the beautiful works of art that are found inside and around the monuments, and on the texts, the visual texts inscribed, the narratives on their walls. And as I mentioned, this is a particular problem, and this is not a problem that's just noticed by archaeologists. Even Sidez himself, who translated many hundreds of these Khmer inscriptions throughout the 20th century, recognized very clearly the limitations of these traditional sources of evidence. And of course, if you go back and read the original translations of a lot of these inscriptions that Sidez made, he was really very qualified in his comments, and was quite cautious in his interpretations that he arrived at as a result of his translations. Unfortunately for archaeologists, these inherent limitations in the inscriptions, which were very well recognized by the people who are working on them, have evolved into a kind of orthodoxy almost in Khmer studies, which is very, very difficult for archaeologists to break and to provide alternative narratives to. And so Sidez here in the quote talks about basically it's these traditional sources of evidence provide us a kind of a skeletal view of ancient societies and cultures without the soul and the flesh. And this is true not only of the temples, which these days represent the kind of stone skeleton of temples that would have looked very different and sat at the center of huge wooden cities. And those wooden cities have effectively disappeared. So this is an artist's reconstruction of an Angkor period wooden city, which, as you can see, doesn't look too much different from the kind of urban context that you might see in rural Southeast Asia even today. And of course, this kind of material has rotted away many, many centuries ago. Houses of stone were essentially reserved for the gods. Everyone else, from the king on down, lived in dwellings of non-durable material, and those that component of the city, which is actually the vast majority of the construction of the city, has completely disappeared, and all we're left with is a tiny piece of evidence in the form of the temples themselves. So what Christoph and I and others have been focusing on since the 1990s is using remote sensing to look at archaeological landscapes in new ways to provide a kind of an additional perspective, a more holistic perspective on urban form at places like Angkor, using various remote sensing techniques. And so what we've noticed is that even though neighborhoods were made of wood, what they did during the Angkor period was they piled up mounds of earth to build those wooden neighborhoods on top of, to stay above the floodwaters in the wet season. The neighborhoods have disappeared, but the mounds remain. They also excavated ponds to keep water during the dry season. Again, most of those ponds have dried up, but we can still see the traces on the surface. Linear features we can sometimes very clearly recognize as canals, others are very clearly roads or dams, And we've also been able to identify a particular type of temple structure, not a kind of huge stone monument, but what you might call a neighborhood temple or a neighborhood shrine, consisting of a mound surrounded by a moat. The moat normally has a causeway on its eastern side, giving the whole ensemble a horseshoe kind of looking shape, a very distinctive shape. And these neighborhood temples may not look like much on the ground. Very often you find nothing actually, and you wouldn't even know that you were standing on top of an Angkor period temple. Nonetheless, these were the basic building blocks, the urban fabric of Khmer cities and Angkorian society. The patterns don't look like anything from the ground, but from the air we can see them very clearly. And so, looking from above, for instance, you can see two of these moated mounds here, connected by causeways to rectangular reservoirs with a series of ponds and mounds around them. And the essence of what we do essentially is trace around those features, interpret them, and create archaeological maps based on those features. And this has allowed us, since the 1990s, to move from these very, very simple schematic maps, which were the best available maps of the greater Angkor area in the 1990s, which just showed the largest of the water management features. It showed some lines. People often didn't know whether those were canals or roadways, and a series of points in the landscape which appeared to be temples disconnected from the center of Angkor, scattered across the landscape. The work that we've been doing using remote sensing has allowed us to move to a much more comprehensive and sophisticated picture of Greater Angkor, including adding nearly 1,000 additional temple sites to the inventory of known temples in the Angkor area, and really coming to terms with the scale and the complexity and the sophistication of this enormous urban complex. And so that was the map that we published in 2007, and it's really difficult to appreciate the sense, the scale of, to get a sense of the scale of what was achieved here. So Angkor Wat, by some measures, the world's largest religious monument, is just a tiny speck in the middle of that vast urban space. And in fact, if we look at that map of Angkor, we can see that it's comparable in terms of its size and its scale and its structure to these modern megacities that have become a defining feature of the way that we live in the post-industrial era. And so there, for example, is a map of Bangkok, the greater Bangkok area, on the same scale as that map of Angkor, which gives you a sense of the scale of what was achieved in Angkor 800 years ago. Of course, what we've been interested in is the role of water management, which facilitated that rise and perhaps caused particular problems with the environment that impacted on the sustainability of the civilization in this particular area as well. So we've been looking at the dynamic interplay between humans and their environment, and the idea that perhaps mastery of the water was the secret of the success of the Khmer civilization, but at the same time sowed the seeds of their downfall. And in fact, the reason why we do this work is not just to uncover lost cities and so on, as the press would have you believe, but in fact this work at Angkor is embedded within a larger project of comparative urbanism, in which Angkor can be seen as a kind of unique test case. It's in a way a kind of archetype for these types of cities that have become a defining feature of modern urbanism, and therefore provides us with a kind of laboratory for understanding the way in which these cities grow and ultimately fail. And so there are lessons to be learned from the study of places like Angkor, which resonate into contemporary society. Issues of, for instance, large-scale infrastructure being inertial, being very, very difficult to adapt and change to social and environmental processes, which are changing quite rapidly, and these kinds of issues. So that's why we do what we do. We also have a branch of our project which deals specifically with climate science and looking at issues of the resilience and sustainability of the water management system in the face of long-term and also short-term climatic changes over the last 1,000 years. So that's basically the theoretical overview of our project. So that brings us up into the work that we're doing very recently. Up until 2012, we were producing maps like this quite happily, but there were always blank spaces in our maps. If you look in the central area here, you don't really see much going on in the area of Angkor Thom and around Angkor Wat. This is supposed to be the densely inhabited downtown area of this vast city, and yet there seems to be a lot more going on out in the extended hinterland. Also, the idea is somehow that the city encroached on these forested areas to the north and created serious environmental problems as a result of it, which played a role in the downfall of the water management system and the city. And yet you see that these are by and large blank spaces on the map. That's not because there's nothing there. That's because you remember we're mapping the traces of this city, of this civilization, by looking at these subtle undulations in the surface of the landscape, these lumps and bumps in the ground, which you see everywhere you go, and which don't make sense to you on the ground, but reveal themselves to be highly patterned spaces when viewed from above. Of course, where you have dense forest, it obscures that view, thus these large blank spaces on our maps. And so there you can see, for instance, Angkor Wat, as I showed you before, completely surrounded by vegetation, and thus obscuring the city, which we always presumed lay around that particular temple site. The solution came to us very recently in the form of a technology called LiDAR, a kind of airborne laser scanning, in which we attach an instrument, a laser instrument, to a helicopter or to a conventional aircraft. We used a helicopter for various reasons in Cambodia instead of a normal airplane, but you can use either. And LiDAR is really a revolutionary technology that's causing quite a radical rethink of the archaeology of particular regions, especially in the tropics, places like the Maya world, the Khmer world. And there's a misconception, actually, that LiDAR is doing this because it somehow has the ability to penetrate or see through vegetation, or that it somehow can see beneath the ground, which is actually a popular misconception. The lasers don't actually penetrate or see through anything. What they do is they exploit the fact that even in the densest, most dense jungle canopy, there are always little tiny gaps in the vegetation that allow light through. And basically, the principle of LiDAR is essentially that the aircraft blankets, it carpets the landscape with so many pulses of LiDAR, millions every few seconds, that at least some of those pulses are bound to find their way through these tiny little gaps in the vegetation and bounce back off the forest floor. And so as the aircraft flies along, this is basically what it's seeing underneath. As you can see, almost all of the returns are coming just off leaves, branches, vegetation, but a very, very small percentage of those pulses are finding their way through the gaps to the forest floor. What we can do back in the lab is basically filter out that vegetation from the picture and leave ourselves with a nice picture of the topography underneath the trees. It's obviously not just in a single line like that. The aircraft takes a swath of data 100 meters, several hundred meters wide as it flies along. Again, most of that is just vegetation, but we can go back to the lab and basically strip that vegetation from the picture. And we just fly very, very systematically over the landscape, collecting billions and billions of points, again, most of which come from the trees, but at least enough of them hit the ground to provide us with very, very high resolution pictures of the archaeological topography, this patterned space underneath the forest. And so here you see, for example, the results of some of our recent work in Phnom Kulen in 2015. This is what you see normally with aerial photographs and conventional imagery, just forest areas that people are clearing for cultivation. That's a representation of the data that can be removed, or the non-ground points that we're lifting away, and there is what's revealed underneath. This archaeological landscape consisting of state pyramid temples that were the center of the king's royal city, temples scattered around, a system of roadways connecting all of those temples, and in the case of, in many areas, these highly geometric arrays of mounds and geometric patterns that we can see in the landscape that are clearly artificial. They're clearly from the Angkor period, and which in many cases we don't yet clearly understand, and yet are clearly part of the engineered landscape of Angkor, and very much integrated into the urban fabric, the urban space of these kinds of areas. So our very first campaign of archaeological LiDAR was in April of 2012. We just used the regular helicopter that people take around for tourist flights. We had the Indonesian branch of a Canadian surveying company, McElhenney, bring in an instrument for us, and we flew for about a week over these forested areas at Angkor and beyond. And so that was our first coverage area in 2012. We didn't do a vast area. It was the largest project of airborne LiDAR that had ever been done for archaeology at the time, but by the standards of LiDAR in general, it wasn't such a huge area. It was very difficult raising money at that time because we had to basically prove the concept, to prove that it would work and that it was useful for archaeology. Thankfully, the results that we achieved were quite spectacular, and it's become relatively easy to raise money since that time. If we take the example of some of the results around Angkor Wat itself, for instance, we can zoom in on this area of the map here. That's what we see from above with conventional imagery, the famous temple there, surrounded by a precinct, enclosed by a moat, and with essentially vegetated areas and rice fields beyond. In the 1990s, my colleague Christophe Potier had, quite remarkably in fact, considering all of that vegetation cover, managed to map a good deal of the archaeological landscape surrounding Angkor Wat. And so you can see evidence of ponds and occupation mounds, of ancient dikes and so on in this particular area. The LiDAR data, however, add a whole new dimension to that picture. And we can see an immense amount of complexity in the archaeological landscape that was essentially invisible to us before because it was obscured by those trees. We can see a highly structured grid within Angkor Wat itself, and we can also see that the structured urban space extends beyond the outside of the moat as well, in every direction. You have this checkerboard pattern of mounds to the west, an extension of the grid to the east, these enigmatic spiral-shaped features to the south, which are huge. We're talking on a very large scale here, plus a very densely inhabited network of roadways, canals, occupation mounds, and ponds. So here, finally, we see this densely inhabited downtown area at Angkor, and that's what the latest version of the archaeological map around Angkor Wat looks like, based on our interpretation of the LiDAR data, which, as you can see, is quite a radical improvement from the types of maps that we had earlier. It's also changed our visions of what the cities around the temples look like. And so here's an artist's impression of what wooden city around Angkor Wat would have looked like. And this was done before the LiDAR imaging was done. And you can see the artist has buildings of different sizes, different orientations. He doesn't have any ponds in there. He has large open spaces. We now know that that was not the case, actually, and that inside the moat of Angkor Wat, you had this incredibly rigidly patterned grid space of ponds and mounds. And so we've had to revise our vision of the city around Angkor Wat to look something like that, in fact, which is quite a serious difference to what it looked like before. And it looks kind of strange, actually. My professor hates this particular image, or at least did hate it, because he said it looks just like a Roman army encampment. We can't have it looking like that. But I said, well, what am I supposed to do? You know, this is the way it looks. So eventually he came around, and we published this just last December in the journal Antiquity. because it's what the LiDAR is showing us. And actually, it's quite interesting because it accords quite nicely with first-hand accounts of Angkor that were provided by visitors to the city during that particular period. And so it's a nice convergence of historical and archaeological evidence. One of the most fascinating things about the work at Angkor, the LiDAR work, is that we had this huge walled city of Angkor Thom, built by, well, at least finalized by King Jayavarman VII in the late 12th, early 13th century. This huge walled city of 3 kilometers on each side. And this is fascinating, actually, because inside its enormous moat and walls is essentially forest, and we have the very famous Temple of the Bion in the middle with its face towers and so on. And this was a tremendous boon for us because there had been a French team who had been working on the ground in Angkor Thom, who had spent about 15 years on the ground with machetes and hand survey levels mapping all of the topography inside the area of Angkor Thom. So they'd been mapping these lumps and bumps in the landscape and had produced this wonderful map before the LiDAR without using fancy technology or anything, which showed us very clearly that there was a beautiful urban grid inside the area of Angkor Thom. It showed us very clearly the layout of the king's royal palace, which was made of wood and has disappeared, but we can see the foundations, we can see the sacred ponds and canals and so on. And this was terrific for us because we had a baseline of data acquired the old-fashioned way against which to compare the accuracy of our LiDAR results. And it turns out that the results of the LiDAR data accord almost perfectly with the data set that was acquired on the ground, the traditional way. The core difference being that instead of about 15 years of work on the ground with machetes and survey levels, we achieved the same result in about 2 hours of flying time. So it gives you an idea of what an incredible leap forward this is for those of us interested in the history of these spaces as lived-in spaces. Also, interestingly enough, the project that had mapped Angkor Thom had begun with the premise that it was a nice walled city with a grid inside that conformed to Indian models of what cities should look like. Thus, the project was designed essentially to look at the areas inside the walls. LiDAR, with its much broader landscape scale perspective, actually shows us that this grid is not constrained to within the city walls at all, but actually extends about 4 times further, is 4 times larger than was previously thought. And so there was a kind of a confirmation bias there that was built into this study by simply assuming that this enclosure actually enclosed what it was supposed to enclose, which it turns out it doesn't at all. So it's basically causing us to completely rethink the way that we look at these so-called walled cities and so-called enclosures, which more often than not turn out not to enclose very much at all, almost invariably, in fact. So one of the things that garnered us a lot of publicity in 2012, 2013 was the results from the mountain plateau of Phnom Kulen to the north of Angkor, where inscriptions refer to a city from the 8th century, 8th to 9th centuries called Mahendra Parvata, whereas all that had been discovered up there up until that point, up until 2012, was basically a series of dots on the map, just of temple sites, and no particular evidence of an urban network existing up there in Phnom Kulen. And that's because this mountain plateau is largely covered by vegetation. I hesitate to say forest because most of it's been chopped down, but you at least have a kind of mosaic of fields and secondary regrowth and that kind of thing. And so you can see that we got just a fairly small area of that mountain plateau, but it was quite instructive in many ways because we managed to find this urban layout using the LiDAR data. And so in this particular image here, what's depicted in green is what we knew before the LiDAR, and what's depicted here in red are archaeological features like roadways and neighborhoods that we discovered using the LiDAR. And so it's a quite powerful illustration of knowledge pre and post acquisition. It also became clear from this kind of study that we had not captured the entire extent of the urban landscape. Obviously, these neighborhoods and streets didn't just somehow stop at the edge of our acquisition. So that was among the driving forces to apply to the European Research Council on the part of the EFEO. The ERC generously agreed to fund a second greatly expanded LiDAR acquisition, once again the largest ever undertaken anywhere in the world for an archaeological project, which we completed in March and April of last year, using much the same technology, the same helicopter, the same LiDAR service provider. One of the things that we did, obviously, is we extended our coverage to include that entire mountain range to try and find the full extent of the urban grid up in that area. And we also extended the coverage to include various other parts, significant archaeological sites in Cambodia as well. The capitals that came before and after Angkor, provincial military outposts, provincial military and industrial centers, corridors of transportation and industry, iron working sites, and these kinds of things. So what we ended up with out of that was a quite unique collection of LiDAR data, which shows us the mechanics of empire, the urban and industrial spaces, really stretching back from prehistory, from 2,000 or 3,000 years ago, up until the present day, capitals down near Phnom Penh. Which provides us with a wonderful kind of laboratory and analytical space that allows us to look at these dynamic interactions between humans and their environment over very, very wide scales of time and space with exceptional clarity and with very, very consistent data sets for each of those places. Among the findings were the extent of Mahendra Parvata, the full extent of Mahendra Parvata. It turns out that we actually caught most of it the first time around, and then it doesn't extend greatly beyond what we got the first time, which is not to say that there's nothing up there. It's just that this particular city doesn't extend up into those areas. So we've effectively solved this problem of how large and how extensive this city, among the first of the capitals at Angkor, actually was, and it's about 50 or 60 square kilometers in size, so about the same size as modern Phnom Penh, for example. It's not a small city either. Just to give you an example of the kinds of things that we're finding in places like Phnom Kulen, many of you will be familiar with places like this. There's a couple of them that exist up in those mountains. This one here is known as the River of 1,000 Lingas, which is a natural sandstone riverbed which has been carved with Shiva Linga. The water flows over those Shiva Linga and is kind of ritually consecrated or sanctified as it then flows down into the great reservoirs of Angkor. And this is quite a famous site. It's within our acquisition for 2015. And that's what the site and its area looks like using conventional imagery. So if you've got a satellite image or aerial photography, that's all you would see. There's a town there, there's a large waterfall here, a large car park in this area, and some urban development there as well. And you can't even really see the river in this particular image. But anyway, there's a stretch of that river that's a couple hundred meters long that contains these Shiva Linga inscribed into the surface of the bedrock. What the LiDAR data shows is that that's just one component of a huge engineered landscape consisting of these geometric arrays of domes that the LiDAR is picking up beneath the forest and even beneath urban areas as well. And so you remember that there was a village built in this area here, which has probably destroyed a lot of the mounds, but we can still see that there would have been a geometric pattern of mounds in that area. In fact, the LiDAR is so precise that we've identified a new temple right there. If you look at that black spot in the middle of it, that's a looter's pit right in the center of that temple. And so we're getting centimeter level accuracy beneath the forest canopy. And these are in areas, as I mentioned, that are heavily forested and in some cases urbanized as well. in which these things are totally obscure to us. We would never have been able to find these things without this technology. Another set of very interesting results comes from the 12th century military-industrial outpost of Prakan of Kompong Svai, which is quite interesting, actually. It's in open woodland. It's the largest enclosure in all of mainland Southeast Asia, 5 kilometers long on each side of that enclosure. And we'd spent years and years working here at this site, trying to figure out what was going on inside that enclosure. Why did they build this enormous moated space with its vast walls and so on? And as late as last year, we were publishing new maps of the site that looked like this, which includes a lot of ironworking and industrial sites inside the temple walls, but we had basically concluded that there wasn't much else going on in there, and that perhaps it was an unfinished or incomplete project that was abandoned and later reconfigured for use as an industrial metalworking site. Unfortunately, or perhaps fortunately, depending on your point of view, not too long after we published that, we got the results of the LiDAR data in, which revealed to us a completely different picture of what's going on inside that enclosure. And in fact, if we zoom in and have a look at a detail of a particular area, you can very clearly see that there's a city in there. There's an urban grid divided up neatly into city blocks, just like Angkor Wat and Bang Melia, other major cities of the 12th century, which extend not only inside the moat, but also far beyond as well. You can see the ponds, the canals, this vast urban landscape revealed by the LiDAR. And it's not like we had just taken a cursory look at this place either. We've been studying this place very, very intensively since 2007, using aerial photographs, pedestrian survey. We had applied radar to the site, satellite imagery, everything that you could possibly think of. And we were producing these kind of very primitive maps that all of a sudden are made completely redundant by the new data. And so that's what we published, unfortunately, just in December of last year, and we were a little too late to stop that from going to press, because it doesn't look like that at all, actually. We now know that it looks like that. Again, a radically different picture from what we had before. And it's not enough, obviously, just to kind of sit in the office and identify nice patterns in the imagery and so on. A lot of what we do actually involves going out into the field and verifying these features on the ground and documenting what we find. Often with the help of local guides, but we load the LiDAR data onto GPS units and go out into the field and check these things out on the ground. And when I say that we've added 1,000 new temple sites to the register at Angkor, of course we shouldn't imagine that there's some huge stone monuments or anything. In fact, the last of those was found at Angkor in 1914. On a good day, we find a brick or two in the middle of a field or something like that, which doesn't look like much, but you have to remember, once again, that during the Angkor period, houses of stone were reserved for the gods, essentially. And so what you're looking at here on the surface is the remains of what would have been a quite large brick structure that would have been the focus, the sort of basic building block of a community consisting of hundreds of families. So this is a very, very significant find, even though we're sort of looking miserably at this one brick that we trekked half a day to get to. It's actually quite exciting in terms of the discoveries, just kind of in retrospect, that's all. So I thought I'd finish the talk this evening with looking at, so we've looked at some of the results in Cambodia. We'll continue to have a look at some other results in Cambodia, just a last couple of interesting examples, but also to look at how we might think about expanding the application of this technology to other countries in the region. And there's several projects in the development stages at the moment, including here in Thailand. I think it's important to understand the key differences and limitations and advantages of using this technology, not only in the Cambodian context, but also in other places as well. One of the great advantages for us at Angkor is that the LiDAR has fostered really a community of researchers who have come together and used the LiDAR data for a vast array of different purposes, for studies in ecology, archaeology, heritage management, hydrology, and these kinds of issues. So we've established basically a community of scholars focused around using the LiDAR data sets as a kind of baseline platform for understanding broader scale landscapes in which we can fit in and put other data on top of and contextualize data at a smaller scale. So we're working with many partners at the moment on the LiDAR data, and we're adding new names to that list all the time. We've looked in some previous slides about the ability of LiDAR to identify new features in areas that are forested, that are mountainous. I've also showed you an example of how we can see features even underneath a modern village up there in Phnom Kulen around the river of 1,000 Lingas. And it's important to remember that even if the highest value of LiDAR comes from applying it in heavily forested areas, there's also a good deal of value to be gained from using the technology in areas that are urbanized, that are open, and that have been subjected to processes like mechanized agriculture and so on, as indeed much of Thailand has. So just to give you an example of some of those results, around the very famous temple of Bante Sray, for example, this is our conventional view of that area. There's the temple of Bante Sray itself. And what you see around Bante Sray is this quite complicated patchwork, a mosaic of scrubland, farmland, built-up areas, plantations, and there's a dam here, probably an Angkor period dam associated with the temple. And so it's a quite open, well-developed, and quite heavily devegetated area. And the LiDAR provides, even in this instance, a whole new dimension to our view of the landscape. And so once we strip away those vegetations and the plantations and so on, we can see that there are patterns associated with the temple here. That there are there's archaeological topography indicating perhaps a field system or some kind of extended system of habitation, which is quite interesting actually, because there are inscriptions at Bante Sray that specifically refer to the existence of a city surrounding the temple, and so perhaps those are components of that city. You can see ancient rice fields here remaining on the surface of the landscape. There's not much remaining of them today, but those little lines of lumps in the landscape are actually termite mounds. The termites prefer areas of the landscape that are slightly higher and drier and don't get so heavily inundated during the wet season. And so the termites, they're building their anthills on top of where the ancient rice fields used to be. So the ancient rice field walls manifest themselves on the surface as a couple of centimeters of relief, but very conveniently we have these nice little anthills all in a row along these higher and drier areas. And so we can see ancient rice fields thanks to these termites. Also, what you can see here is an example of what I showed you before up in Phnom Kulen, one of these geometric arrays of mounds in the landscape. You can see there's an enclosure here and there's part of a grid in this area. Probably it continued in that area and it seems to have been obliterated. In fact, I think there's a papaya farm or a mango farm or something there now where the farmer has used a bulldozer to basically wipe out what's there. But even in spite of the existence of that plantation, there are the obvious mounds. You can still see the ghostly traces of that original pattern, that grid pattern of mounds in that area. And if we manipulate the LiDAR data, we can sort of tease out these kinds of details, even in areas that where people have very deliberately attempted to erase all of the topography in order to create what they believe to be a perfectly flat landscape. But we're nonetheless picking up these centimeter scale variations that remain on the surface. So it's very useful in open areas. Another example of where it's useful in urban and open areas that are in some ways analogous to what you find in other parts of Southeast Asia are results that we got from the site of Longvek and Udong, the site of the post-Angkorian capitals, the capitals of Cambodia from the 15th century, mostly right up until the present day. And this is a typical example of what that area looks like. You can see the edge, the corner, the northwest corner of a walled city that was probably built sometime in the 1400s or 1500s. Then you can see modern development. There are brick factories and rice mills here, unfortunately, which are destroying this heritage and these walls, by the way. So just to make an aside that there's an urgency to doing these LiDAR acquisitions. We need to be able to document these heritage landscapes before they disappear. But in any case, it's a sort of typical mosaic of open land, industrial areas, and here this grid that you see here is a modern military base, and you can see they're doing a lot of clearing and road building around there as well. If we remove that picture and have a look at what it looks like in the LiDAR, there's the modern square military base there with the officers' houses and so on. But you can see that they've actually built that military base inside the very, very subtle remains that we see there of what's probably a 19th century or 18th century fort, perhaps built by invading forces. So we can see relics, remains in the surface of the landscape, even under heavily developed areas that have been intensively modified. You can see the ramparts there, even on this ditch. You can stand on this today and not even see it, but just coincidentally, this military base happens to have been built in the confines of this fort, which is probably hundreds of years old. It's not just urban spaces that we're uncovering and looking at using the LiDAR data. One of the really interesting outcomes is that we've been able to look at patterns in the data and identify particular types of industrial activity like quarrying and mining. So we're beginning to understand much better the mechanics of empire, where particular goods came from and went to, how they were transported, the scale of the industries that were common during this particular period. And one of those industries is quarrying. And so what you're seeing here in the LiDAR data, this is with the vegetation removed, is a quarry. And this is actually a fairly well-known quarry. You can actually see the exposed stone and the chisel marks in the surface. And so that had been documented in that area. What people had missed is that there were two gigantic quarry fields just nearby covering several hectares. And the reason why people had missed those is because they're covered over by dirt. Okay, so these are pit quarries that have been dug into the ground, and these days you can't see them on the surface at all because they're obscured by a layer of topsoil. But nonetheless, because they were pit quarries that were carved into the landscape, there's these subtle concave lenses in the landscape that give these very subtle patterns, but yet very distinctive patterns. And you can excavate those and basically see the remains of quarrying, being able to confirm that those are quarries. So this has been an interesting outcome. Again, doesn't look like a quarry at all on the ground, but we first realized that we were looking at quarries. We wanted to know what these strange things were that we were seeing, and we went there and found mountains of stone chips, which didn't really make any sense until we realized actually that what we were seeing is basically the surface debris of these infilled pit quarries, which has a lot of implications for our understanding of where all of the stone from the temples came from. So as recently as 4 years ago, a Japanese team published a study in which they identified what they regarded to be 50 discrete quarries in this particular area. So everyone's always known that this is where the stone from Angkor came from. They floated the stones down on canals into the center of Angkor, and the Japanese team embarked on a project over many years identifying these 50 individual quarries, which are marked here in red. There's Beng Melia right there, the temple of that area. what they had missed, of course, is the kind of thing that we're seeing now, is that what you have are basically gigantic quarry fields with just occasional surface expressions. And so what we're not looking at by any means is 50 discrete quarries. It's actually one gigantic quarry field in which they've stripped away the entire mountainside for use in building the temples of Angkor. And if we zoom in here on this one particular area of detail, so the red points there are the Japanese discrete quarries, and this yellow hatching here is the full extent of this gigantic quarry field. And you can see, instead of these isolated surface expressions, we have scarring across huge mountaintops, basically, where they've stripped away entire hills. And so for the first time, all of a sudden, the scale of quarrying here meshes quite nicely with the volume of stone that we can actually see at the temples, which was never the case before. It was always curious why the quarries were so small. They're not, actually, at all. Just to give you a final example of this kind of thing, in terms of industry as well, one of the most famous iron producing sites in Cambodia is this area here in the northeast. And once again, we can see examples of areas that have been dug out of the landscape. That may actually be a mine where they're mining ore out of the ground, which in subsequent years fills up, becomes a kind of pond. But those mounds that you see around the site, those are not termite mounds. Those are actually furnaces where they're smelting down that iron ore and extracting iron from whatever they're pulling out of the ground in those areas. And you can see a huge amount of those furnaces scattered around, which are quite distinctly different from the little ant hills that you can see everywhere on the ground as well. And we can see dozens of these in these areas. So it's a vast metal working complex. The other really interesting thing about the LiDAR, and I promise to conclude in a couple of minutes here, is not only the ability of LiDAR to reveal to us features which we knew very well, like roads and streets and canals and ponds and this kind of thing, but its potential to reveal to us things that we had absolutely no idea were there before, and we would never have known were there unless we had used this technology. And these spirals, these geometric coil-like patterns south of Angkor Wat are a very good example of this. We discovered these in 2012 using the LiDAR data. We've done a lot of excavations on them and are still really no closer to understanding what they are at this particular point in time. But again, as recently as last December, we were publishing articles in which we were basically stating that these were unique and unknown anywhere else in the Angkorian Empire, whereas we now know that they exist at several locations, kind of Kampong Svai, around Beng Melia, and so on. And so if we look at this area to the south of Beng Melia, you can see there's the temple of Beng Melia, again a 12th century temple with this very classic urban grid, this neatly divided gridded space inside. And there, if you look to the southwest, you can see another one of those geometric shaped patterns in the surface of the landscape. And this is one of several of those that we've now identified using the LiDAR data. And so it turns out that Angkor Wat is not unique at all in terms of having these features. And who knows where else they might crop up. And that's a close-up. They're not very distinct, not nearly as distinct as the ones at Angkor, but they're definitely the same kind of thing, with the same kind of structure. And so, in conclusion, I've talked about applications of this kind of technology for archaeology this evening, but it also has a wide range of benefits in other fields as well. And so as I mentioned, we're working with a wide range of other teams who are using the data for different purposes. We've been able to use machine learning techniques and field surveys to teach software to recognize individual tree species within the LiDAR data, just from looking at the structure of the trees, the colors of their crowns, and the photography that we take, and this kind of thing. So we can now automate the process of classifying particular species of trees across forests with a reasonable degree of accuracy. And of course, having these wonderful 3D models of vegetation we can also do things like calculate the biomass of particular forests, and which has implications for incentive-based reduction emission schemes and this kind of thing, as well as obvious applications in looking at the forest ecology of these particular areas. And you can see, actually, one of the interesting things about Angkor Thom is that it looks like a very densely forested area full of primary forest, but there's actually not much, and most of the forest is in a kind of thin curtain just by the side of the road, giving the visitor the illusion somehow of going through this giant forest, which actually turns out not to be very true. In terms of the feasibility of using the technology in different parts of the region, the method that we've established by using locally available helicopters, bringing in consulting engineers who just bring the instrument in, using locally available surveyors and so on, turns out to be quite good and cost-effective model of covering very, very large areas. And so that's the kind of basic setup that we have there as we fly around and acquire these LiDAR data. And there's a misconception also that the LiDAR is somehow prohibitively expensive, and that it costs enormous amounts of money, and that we shouldn't really be doing this. We should be devoting the money to much more sensible traditional archaeological projects of survey and so on. In fact, it depends on what your perspective is and how you're looking at it. I've graphed here the cost of traditional ground-based surveys, which essentially remains the same cost per hectare, regardless of how much you survey on the ground using traditional methods, compared to a graph of how much areas cost using LiDAR technology. And it doesn't take very large areas of space until LiDAR becomes a much more cost-effective method of acquiring data than traditional terrestrial surveys. And of course, it gives you a vast amount of data that you would basically be impossible to acquire using traditional methods. And so if we look at, even at the scale of Angkor Thom and Angkor Wat, as I mentioned, instead of a decade and a half and a very large expense, you could do it relatively cheaply using LiDAR. There's a high initial cost in terms of mobilization and demobilization, but once you've met that cost, there's great economies of scale in terms of expanding your coverage area. And so if we were to have done the area that we covered in 2015 using conventional survey methods, it would have cost us something in the order of $12 million to do, whereas in fact it cost us well under $1 million to achieve a much superior result. So it turns out not to be all that expensive at all, depending on your perspective and which particular scale of inquiry you're approaching it from. And obviously this is not just a technology that has great potential in Southeast Asia. At the moment, scholars worldwide are beginning to use this technology in different areas, in particular in the Americas. And so there's a kind of network of people who are collaborating on producing what turn out to be very consistent and comparable data sets. So for the first time, these predictions and these sort of visionary scholars who in the 1950s imagined that we might have a kind of global comparative archaeology in which we would be able to look at different civilizations using consistent and comparable data sets, all of a sudden is being enabled by this particular technology, which is catalyzing a lot of partnerships and new research directions. And in the interest of time, I think I'll leave it there at this point, and thank you for your attention this evening. Thanks.
Thank you very much. I'm sure when, like me, many of you knew already that Angkor was quite impressive. Spectacular monuments, but clearly the picture we have seen today